If one were to travel to Earth 700 million years ago, they'd be met with an inhospitable wasteland. The entire planet would have been covered with vast glaciers, stretching from the poles all the way down to the equator. Biodiversity would have been very low, and most life forms at the time were just barely clinging on to the few spots on the equator that the glaciers had never reached. As crazy as it may sound, there's evidence that this may have actually happened. Scientists have found dropstones, which are rocks that are typically deposited by glaciers, all across the globe, which indicates that these glaciers would have been worldwide. The phenomena has since been appropriately named Snowball Earth, and this event had happened not once, but twice, nearly back-to-back, throughout the period known as the Cryogenian, from 720 to 635 million years ago. But how could such a catastrophic event happen? How was ice able to extend that far, and more importantly, how did Earth ultimately thaw out? To answer that question, we need to go back just before the Cryogenian glaciations, at a time known as the Tonian period. Now, if one were to go back to the Tonian a few hundred million years before, they'd be met with a completely different world. The planet was still going through a long period of relative stasis known informally as the Borean Billion. As the name probably suggests, Earth during the Borean Billion would have been very dull. Oceans were barely oxidized, if at all, and were black in color as the result of high concentrations of hydrogen sulfide, and the atmosphere would have consisted of nitrous oxide, more commonly known as laughing gas. Despite this, life was ultimately thriving. Major plant lineages, namely algae, had long established themselves as a prominent photosynthetic force by the Tonian, and molecular data suggests that this period also saw the emergence of other eukaryotic kingdoms, including fungi, and more prominently, animals. I'll get back to them later. So it appears as though Earth had been doing just fine for nearly a billion years, but that will all soon change thanks to continental drift. At the start of the Tonian, there was only one large supercontinent, Rodina. Later on, however, it began to break up as a result of large continental rifting. This reorganization would have resulted in a decrease in volcanic carbon dioxide emissions, and at the same time, the separation of continents would have also increased rainfall, causing extensive erosion of volcanic rock, which would have consumed even more CO2. Due to being a greenhouse gas, when the carbon dioxide levels began to deplete, so too did the temperature. Glaciers quickly began to extend from the poles, and upon reaching 30 degrees latitude on both ends, there was nothing stopping them. The ice reflected most of the sunlight back into space, which only resulted in further glaciation, and this positive feedback loop continued on until eventually the entire planet was a white, glistening ball of ice from pole to equator. This is what scientists believe was the main cause of Snowball Earth. So Earth remained this way for nearly 100 million years. This frozen wasteland may seem inhospitable, yet in spite of that, life still prevailed. In fact, there doesn't appear to be any sign of a mass extinction at all, so it appears as though life was practically unaffected during Snowball Earth. This has led some scientists to propose that perhaps Snowball Earth was actually more of a slushball Earth, suggesting that Earth wasn't completely covered in ice. Instead, there would have been a belt of liquid water surrounding the equator. This most likely explains how eukaryotes managed to survive the glaciations, as they would still have access to sunlight. Despite that, biodiversity during the Cryogenian was, unsurprisingly, very low. On the surface lies the majority of the Earth's autotrophs, the most prominent being algae. Since their evolution in the Mesoproterozoic, algae had become highly successful, overtaking cyanobacteria as the dominant photosynthetic organisms. To this day, they contribute to at least 70% of the oxygen in our atmosphere. During Snowball Earth, one group, the Androphytes, were unique in that they resided on land or glaciers, having evolved to tolerate drying out and withstand extreme conditions. While these algae are now extinct, their adaptations ultimately gave rise to true land plants during the Paleozoic era. While algae and other photosynthetic organisms continue to absorb sunlight in the few spaces available, deep beneath the impenetrable ice within the dark ocean depths, one might come across a peculiar organism, Octavia antiqua. To our eyes, it would appear tiny, reaching a maximum size of only 5 millimeters, but compared to most other organisms at the time, it appeared enormous. Octavia was hollow inside and appeared to have small pores that led to the interior of the organism. This has led scientists to believe that Octavia was most likely a sponge, thus making it one of the earliest known animals to appear on Earth. Of course, Octavia most likely wasn't alone. In fact, recent studies have argued that perhaps sponges like Octavia weren't actually the first animals to appear on Earth. Instead, they propose that comb jellies, not sponges, were the first animals to branch off the evolutionary tree. There is still a debate over which came first, but for the sake of this video, we'll stick with sponges as being the first. I definitely plan to go more in depth with both sponges and comb jellies in their own respective videos. So sponges, algae, among other life forms pushed on in the endless snow and ice for nearly 100 million years. It seemed as though this ice age would go on eternally, but as you can probably guess, it did eventually end. While the entire planet was completely covered in ice, that never stopped plate tectonics. As Rodina continued to drift apart during the Cryogenian, volcanoes deep beneath the ice began to emit carbon dioxide, and soon it began to build up. Eventually, carbon dioxide levels were high enough for the atmosphere to warm up, and in nearly an instant, geologically speaking, the Earth finally thawed out of its icy purgatory. The Cryogenian came to an end around 635 million years ago, and things are beginning to change. The volcanism that ended Snowball Earth also caused an influx of minerals into the oceans, most notably phosphorus, a key element of life. This led algae growth to skyrocket, leading to increased oxygen levels and increasingly more complex life. In addition, increased oxygen levels also led to the formation of the ozone layer, which now protects the planet from harmful UV rays. So it appears that, ironically, these catastrophic glaciations may have actually paved the way for the explosion of complex life that follows suit. Tune in next time on PaleoJourney, where we take a look at the succeeding Edenacrian period and the bizarre first attempts at complex ecosystems. I hope you enjoyed this video, and I'll see you next time.